Good afternoon. Well, I'm a W, I'm afraid, not a Y or an X. I'm very pleased to introduce you to Buro Happold and the catch-22 of our industry, which is time, quality and cost. It is the oldest conundrum in our industry and one which we've all been struggling to solve. Traditional construction, as we all know it, really does two parts of this. You can deliver it on time, you can control the cost, but the quality can get compromised. Or you can do it quickly and on cost, but the program takes longer. So with traditional construction, you have issues with large workforces on site and a shortage of skilled labour. And as the cities grow in Asia, and we're looking at 70 million people urbanising in China and India alone, that means the pressure within this is going to get higher and higher as the skill base gets shorter and shorter. BIM has made a big step forward. It started to mechanise the process. We're now producing drawings and product for our development of construction much, much quicker and to higher detail. We're looking at snagging problems and looking at delicate interfaces. This project here is the Louvre, which we're delivering in Abu Dhabi, which is a very complex interlaying steel structure over a museum by Jean Nouvel. I hope you'll all visit one when it's finished. Now, we need to look at how we can solve this problem by learning from industry, from the manufacturing industry. And Henry Ford actually started solving this in 1908 when he turned the automobile from a plaything of the rich to a mode of transport for the masses. He developed a production line. He simplified tasks, he actually de-skilled his labour, and he produced a high-quality product quicker and cheaper than any of his competitors and stole the world of the Model T. The only thing is they all came in black. In our industry, precast is a great start. It is starting to move buildings into large manufactured lumps, but it doesn't solve the problem completely. Detailing is important, and we also got the complexity of plugging in all the building services and the facades, and making the buildings airtight and architecturally as pleasable is always a challenge. A couple of years ago, we developed this project, which is Millennium Point in Birmingham. It was a traditional flat slab, and we modified that with these crossheads. And I'm not quite sure which one to push here, but try this one. Yes, which are these crossheads, which are seated on top of composite columns, very simple select piece here, which seated into the columns with precast panels between them. The building is 50,000 square metres and was constructed in under 6 months. Of a great success. It's a museum, it's an educational centre, it's a shopping centre, and actually an office space on top. So very versatile, very quick. A couple of years later, we were asked how could we move this quicker, and we were by a big hotel chain who did a hotel in Slough, just north of London. And they'd spent 24 million in 18 months building actually quite a simple hotel. And the guy came and said to me, we're not going to ever make any money on this. It's taken too long and cost too much money. How do we do it quicker? So we looked at what he had done and realised the issue was the concrete. The concrete took too long to place and too long to set to allow the finishes to go in place. So we developed a modular solution using container lifting technology, but specifically manufactured boxes. The whole idea of modular solutions is actually when you manufacture them, of course, they have to be designed so you can actually get them on a truck, where's the pointer, from a ship to a truck to the site and then lift them into place. We've actually done a couple of these now, both an open plan and also a closed system. We've done 8 hotels up to 16 stories high. The rooms go up every half an hour, and the rooms come fitted with all the internal fittings, the bathrooms, all the communication systems, the air conditioning, even the glass in the door. So when the door is locked on factory, it's inspected when it arrives to site, lifted into place, and then locked again. And only unlocked by the user who wants to put his carpet and final fit-outs into the building. Very successful. On these type of buildings, we're actually reducing the program by at least a third, or even a half, which makes substantial cost savings. In essence, when we actually looked at this in full, as Henry Ford discovered, we were actually looking at a cost savings of, in essence, about 20 to 25%. This has moved on into from the hotel industry into hospitals, into schools, into residential, and even office buildings. And the limit is only our imagination. The big plus of these type of buildings is they're easy to assemble, but also these days when sustainability is such an important play, We need to look at how we deassemble them. How do we recycle these buildings? And when you have very simple connections and fixings, such as this, when you finish the building, you can actually dismantle it, take it away, refit it, and take it somewhere else. So we haven't done that yet. The buildings haven't run their life, but it is a feature that will actually come into play. One project we are looking at in London, that's exciting this, is a laboratory attached to a hospital just in the centre of London. The essence of laboratories, they deal with some product which isn't actually very palatable to the community. So if you've got a building that you can actually just lock up and dismantle and take away and deal with things off-site in a very clean environment and safe environment, it is an added advantage to such facilities. Now, of course, it doesn't just stop at actually regular shaped buildings. The British Museum is something we actually finished in 2000. And the British Museum was actually the forerunner for us to BIM. It was our introduction to BIM, where it was all designed in 3 dimensions, drawn in 3 dimensions, as actually a 3-dimensional shape. The roof was at that time the largest glazed atrium, should I say, in Europe. And it was delivered on time and on budget. And it was done so by actually giving our design and our computer modelling to the contractor and working with him to actually to hire robots from BMW to actually manufacture the 6,600 separate elements which make up that roof. The nodes themselves were cut robotically. And what we discovered with robots, firstly, they don't stop for smoko, they don't enjoy lunch, and as long as you keep feeding material, they'll even work a weekend for you at no extra cost. This building was then assembled into what we called ladders, which is the last slide here, which were delivered into site on a just-in-time basis, and the whole building was assembled very, very efficiently to plus or minus 3 millimetres. And this is my last slide. It's the Cutty Sark, which we completed last year, which is one of my favourite projects. Again, a truly 3-dimensional project which had to be completely manufactured off-site and assembled into Britain's only listed ship. Thank you very much.